Hey everybody, welcome back to another fun and exciting intermediate math class. In today's lesson, we'll be starting into chapter number 10. This is a big moment for you because that means that you are 3/4 of the way done with this book. That is 75% done. You only have 25% more to go. So keep working hard. The end is near. It's coming. So keep going. Chapter 10, lesson number 1 is on page 402. Page 402. We're going to be talking today, and we're going to be starting off. This is really a lot of algebra going on here. So we're going to be talking about adding and subtracting like terms. Let's take a look down here. What is a like term? Well, before you can combine them or add them or subtract them, you're going to need to know what it is. What is a like term? So here's what it is. A like term has the same variable. What's a variable? You could write same letter there. So it has the same letter like x. Let's say x is your variable, okay? And it also has the same exponent. So let's write it 2 as the exponent. So in order for something to be a like term with x squared, you would have to have the same letter x and the same exponent 2. These two things are like terms. Now you might say those are exactly alike. You're right, but I could change them just a little bit and keep them as like terms. What do I mean by that? Well, I could put a 3 out in front of one of these, and I could put a negative sign out in front of the other one, but I still have like terms. Look, the negative sign doesn't matter because notice it doesn't say down here that it has to have the same sign. I can put a 3 out in front of this one because notice it doesn't say it has to have the same coefficient. That's what this is called, is a coefficient. It doesn't say that. Here's what it says. The same variable, or you could say the same variables with an S. So it could be the same variables. What do I mean by that? Well, you could have something like 3xy, and you could say 7xy. Those would be like terms. So if it's the same like grouping of variables, fine. Now here's what's not a like term. 3xy and 3xy squared. Those are not the same. Okay, why not? Because notice the same exponent is not true. Because the one has an exponent of, technically, this y has an exponent of 1. We never write that because we don't need to. But the other one has an exponent of 2. So those are not like terms. Okay, so these would not be like terms. These would be like terms. These would be like terms. All right, so let's play a little game here. You're going to tell me yes or no. Are these like terms? I know you can't tell me, but you can talk, and you can even talk out loud. Give me a thumbs up, give me a thumbs down, whichever. All right, so play the game with me, all right? 2x squared and 2x squared, are those like terms? Yes, those are like terms. Why are they like terms? Because the letter is the same, x and x, and the exponent is the same. Does the 2 out front matter? It doesn't. It could be 2 and 7, okay? As long as the x is the same and the x squared is the same. So those are matchy-matchy. Those work. Good. How about this one right here? 3ab and 3ab squared. Are those like terms? No, they are not like terms. Why are they not like terms? Because the AB is the same, the letters are the same, but the B has an exponent of 2 in the second one, so that is not like terms. All right, how about the next one? 5y squared and negative 5y squared. Are those like terms? Yes, those are like terms. Why are they like terms? Because the y is the same and the squared is the same. The exponent is the same. Very good. All right, you guys are getting good at this. At least I hope you are. I don't know if you are or not. All right, this next one here, we have negative b and just b. Are those like terms? Yes, those are like terms. Why are they like terms? Because you have the b is the same in both, and the exponent is the same, or in this case, the lack of an exponent. All right, and then down here, the last one, we have 2xy cubed and 2xy squared. Are those like terms? No, those are not like terms. Why are they not like terms? Because the first one has a y cubed and the second one has a y squared. All right, there's the basics of it. Let me give you a little analogy. I'll tell you a little story. We'll have a little fun here, okay? So if I go to the grocery store and I am shopping for fruit, okay? And I want to get some apples and I want to get some oranges and maybe some bananas. So I want to get some different kinds of fruits. So when I go and I start shopping for these things, is it a good idea for me to just put the apples and the oranges and the bananas all into the same bag as I'm shopping? So this lady here is putting different fruits in. Is it a good idea for her to put the different fruits in the same bag? All right. And you might be thinking, yeah, why not? Or you might be thinking, no, you can't do that. Why can't you do that? What's the problem with putting all of your fruit in the same bag? Well, you're adding it to the same bag, and then when you get up to the register to pay, the person there at the register is going to say, I need to separate these. I need all the apples together. I need all the oranges together. I need all the bananas together. Why is that? Because they put them on the scale, they weigh them separately, they count them separately. Apples cost a different amount than oranges, and oranges cost a different amount than bananas. Okay, so the concept is the same when we're dealing with like terms. We want to put all of the bananas in the same bag. We want to put all of the oranges in the same bag. We want to put all of the apples in the same bag. So going back here, this is like, okay, the x squareds are all the apples, and the xy's over here are all of the oranges. And the y squareds, this one that I had here, or the xy squareds, are all of the, whatever, strawberries or whatever fruit or whatever vegetable you want to put in there, okay? So you have to separate them out. Why am I telling you this? Because we're going to combine like terms. We're going to add them together, okay? All right, so the next thing that we want to do is we want to combine our like terms, and only our like terms. We can't combine anything we want to combine. This is where we're putting the fruit in the bag, okay? So now, question. In this first one right here, which ones are like terms? Let me show you what I like to do with them. When I find a like term, I like to circle it or put a box around it or underline it or something so I can say, okay, those are like terms. So 2x plus 3x plus 5. Which ones are like terms? Well, there's a 2x and a 3x. So those ones have the same letters and the same exponents. Notice this one does not have a letter with it, and so we have to separate him. He's a watermelon, okay? So we have apples and watermelons here, and we can't combine the two. So what we want to do is we want to add these two together. So you would say, if I have two x's, let's call x's apples. If I have two apples, and I take 3 more apples, and I put them all in the same bag, how many apples do I have? I have 5 apples, okay? So I have 5 x's over here. And over here, all I have is a 5. I don't have anything to combine it with, so I would just leave it the same. There's nothing to add to it. This would be my answer. Now, this is where students tend to lose their minds sometimes because you're like, wait a second, I've never really had an answer like that. I want it to be just 5 or 3x or something like that. Well, sometimes in algebra, your answers are going to have a plus sign or a minus sign in them because you can't combine anything else. So for this one, that's your final answer, 5x plus 5. Circle it, done. Don't try to combine anything else because those are different types of fruits. I know they're not fruits, but I'm trying to help you see the analogy there. All right, next is 7b cubed plus 4b squared minus 10b squared minus 4b. All right, so again, I like to do things, so let's circle all of the cubed terms. Well, I only see one cubed term. Let's put a box around all of the squared terms. I see two squared terms, and then let's underline the term with no exponent. Okay. Now that will help you if you'll do something like that, figure out some kind of a system to use, and that way every time you get to one, you'll separate everything out, and that will really help you. Okay. So what do I combine or add to my 7b cubed? Nothing, because I don't have any more b cubes. That's the only b cubed in this problem. So I have a 7b cubed. Now, what I would do with this next one right here is I would say, okay, now theoretically, this isn't real because we're dealing with fruit. You can't really have negative fruit, but let's say that I have 4 bananas in the bag. Okay, that's this right here. I have positive 4 bananas in the bag, and I subtract 10 bananas. Well, I can't really do that. Theoretically, I can't. But, in algebra, I can. So if I have 4 in the bag and I take out 10, that means I have negative 6 bananas. The b squareds, in this case, are the bananas. Okay? So I have negative 6 b squared. That's how you combine like terms. Sometimes with like terms, you're subtracting. Sometimes you're adding. It all depends on what these signs tell you to do. Okay? So if I have 4 and I take out 10, that means I have negative 6. And then the last one is over here, this negative 4b. And you say, is it negative 4b or is it minus 4b? It doesn't matter. It's the same thing. You'll figure that out the farther you go into algebra, that negative 4b and minus 4b means the same thing. There's no difference there. So I'll just say minus 4b. And there we go. That would be our answer for that one. 7b cubed minus 6b squared minus 4b. All right, a little bit of a shorter lesson there. Hopefully you that connected for you, the whole idea of going to the supermarket and buying fruit, because I think we can all relate to that. We've all done that or been with mom at some point when she's been buying fruit. So yeah, you have to put the same fruit in the same bag. So you can only add apples to apples. You can only add bananas to bananas. So be careful. What has to be the same? Two things. The exponent has to be the same, and the letter or letters have to be the same. So you can't have xy and combine them with xz. That doesn't work. Xy and xz don't combine. That's a cantaloupe and a watermelon. Those are two different fruits, and we can't combine them. So be careful with that. Make sure that you practice this. If you missed anything in the lesson, go ahead and slide it back. Watch it again. We'll see you later. Have a good one. Bye-bye.